Today we are going to study what is surface tension. So to know what is surface tension, first of all we need to know what is cohesion or cohesive force and adhesion or adhesive force. So cohesive force means the force between two similar kind of or two same type of material or molecules, and adhesion is the force between two different types of molecules. For example, the force between two water droplets will be cohesive, okay, and the force between water and glass will be adhesive force, okay. So what happens at the surface of the liquid or any fluid? Here you can see if the particle is inside the liquid, then all particles inside the liquid adjacent to that will attract the particle, the molecule, and that will be the type of cohesive force. That will be cohesive force. But if you look at the particle or the molecule at the surface, there will be cohesive forces from the particles beneath the molecule in the surface, but there will be adhesive force from the air molecules. And as the density of air is very less compared to the liquid, most of the cases this force is very less, and therefore the net downward force is acting on the surface of the fluid, and this becomes a stretched membrane, and therefore the force per unit length is called as a surface tension. So this is only a surface phenomenon. If you go beyond this in the depth, there will be no surface tension. It is only on the surface. Therefore, we call it as a surface tension. Now, because of this stretched membrane, there is an additional potential energy, and that is called as a surface energy, and that is given by T into dA. This is T is the surface tension again, and the A is the area. Sometimes we need to change the area, and in those cases, we will see in the soap bubble or the liquid drop, we will use the change in area to calculate the surface energy. Now, we have different type of angles of contact. So now, depending on the solid and liquid interaction, we have different types of angle of contact. Mostly we will see there are acute angles or concave angles. So what is this angle of contact? This is angle of contact. This angle is between the surface of or interface, we can say, of solid and liquid, and the tangent to the surface formed at the topmost level. So why it changes from the straight line to curve? Like here we can see that is concave surface, if you see from above, and there is a concave surface, okay. So this surface is like this, and this surface is like this, okay. So why it happens? So that we will see. Now, because there are two different types of forces, one is the adhesive force and one is cohesive force. Depending on liquid and the solid pair, this force of attraction between solid liquid and liquid liquid may differ. So in the case of in the first case where this meniscus is concave, what happens is the adhesive force is more than the cohesive force, and therefore the resultant force is in the solid, and therefore to balance this, because the resultant force should be always normal to the surface, this liquid rushes above to the solid surface, and you can see this tangent in this direction, and this angle is in between this interface and this tangent. Again, in the case of convex surface, what happens is the force of cohesion is more than that of adhesion force. So what happens is the resultant comes in the liquid, and therefore the tangent is formed such that it is perpendicular to this resultant force, and therefore the liquid seems to be get down in the near to the surface, and therefore this angle from this surface interface of solid and liquid and this tangent is called as the angle of contact. So remember, this angle of contact is always measured within the liquid. Now this type of liquids does wet the solid, and this type of liquids does not wet the solid. The example for this is for this acute angle is water and glass, and for obtuse angle, it is mercury and water. Now there can be a possibility of zero angle of contact, and this is a rare phenomena. In this case, the cohesive force is so much less that the resultant force is directed in the solid and it is equal to the force of adhesion, and therefore the tangent is on the interface of solid and liquid, and therefore we can see the angle between this interface and the tangent is 0 degree. Now this is very rare phenomena. This can be found in the case of pure water and clean glass. If we place a drop on the solid, they can form a different shape. So what we see here, this acute angle forming the concave meniscus having the liquid. Such liquids they form like this shape. And the other type, the angle is concave. You can see here this angle is concave here within the liquid, and here it is a obtuse in this case. Now here using the if this liquid is at rest, we can use the Newton's law and we can use forces and balance them in this direction and in this direction. So in this direction there is a tension between solid and air. Here the tension is between T1 is tension between liquid and solid, and there is also tension between solid liquid and air. So if we use this, we will get this equation, and cos theta is this. So for this case, because cos theta is or theta is obtuse, theta is acute, cos theta will be positive, and therefore T2 is greater than T1. So you can use this formula. And in case of in this case, angle is obtuse, so therefore cos theta must be negative, and therefore T2 must be less or T1 must be higher. Now there are some factors affecting this angle of contact. That is the nature of solid and liquid. Just as I said, if the liquid is changed, so from water to kerosene or to oil, there will be change in angle of contact. Now if there are some impurities, then also there will be change in the angle of contact, and there will be change due to temperature. Now if we see the effect due to these factors on the surface tension, this is for angle of contact. Similarly, how surface tension is going to change? So if the soluble impurities are there, the surface tension is going to increase with the increase in impurities. On the other hand, if the impurities are insoluble, then the surface tension is going to decrease. Okay. So well-known example for this insoluble impurity is the soap. When we use soap or detergent, this is to decrease the surface tension, and this decrease in surface tension enhances the surface area and cleaning becomes easier. Now with the temperature, as if you increase the temperature, the surface tension decreases and again the area increases. So if you clean the utensil with the normal water and with the hot water, you can see the hot water makes the utensil more cleaner. Okay, so this is because the surface tension decreases at the higher temperature. Now because of this shape, and you can see there is some force. So force per unit area, there is some pressure difference. So this excess pressure is calculated for liquid drops and soap bubble for the most of the time, but here is also pressure is different inside the liquid and just outside the liquid. So now we can use this formula. How to find whether the pressure is more inside or outside? So for that you can use the trick that on the concave side the pressure will be higher. Okay. So in case of this type of liquid, this forms the acute angle. Concave side is this. So here the pressure will be higher. On this side, so outside pressure is higher, and here inside the concave side is there. So inside the pressure will be higher. So there is concept of capillary action. So capillary is the glass tube which has very small diameter in the range of few mm. So when we did this, if the pressure inside is less, then what happens is this rise in liquid inside the capillary happens to maintain the pressure at the equal height. So at this point and this point inside the capillary. So to maintain the pressure, this liquid rises in the capillary. So this is called as a rise in capillary or capillary rise. Similarly, we can see the dip in the capillary in case of this second type of liquid which does not bite the solid. So here the pressure goes down here, and therefore to maintain the pressure the liquid column decreases or it gets out of the capillary. Now what are the examples? If you see, the trees carry the water from ground to the topmost leaf of the tree. So that happens because of this capillary rise. Or you can see, if you put the bread in the milk, that absorbs the milk. So that is also because of the rise, capillary rise. The formula can be easily derived with the pressure difference. So H rho G is equal to 2T upon R. When T is the surface tension and R is the radius of curvature of that liquid at the point. So suppose this is the curvature of the liquid. So this will be R. So this is the angle theta. So if this radius of the capillary is small r, then we can convert this into r and cos theta. So suppose this is the angle theta, because this is the angle theta, you can easily from the geometry of this you can find out the angle, and you can find the relation, that is capital R cos theta is equal to small r, and from that you can write r is equal to small r upon cos theta, and if you substitute here you will get this formula, and using this formula you can find out how much rise or dip will happen in the capillary, right? So if you just rearrange this formula, you will get H is equal to 2T cos theta divided by R rho G, where all terms have their usual meaning. T is the surface tension, R is the radius of this capillary, rho is the density of the fluid, and G is the acceleration due to gravity at that particular point. So this is enough for today's lecture. If you have any queries or doubts, you can comment me below and I will try to answer those questions. If questions are more, then I will make separate video on them. Thank you for watching.